Hello, this is Mr. Stansbury. I'm going to take you through the 7A notes on distance between 2 points. Okay? At the end of this, you should be able to find the distance between 2 points and be able to determine the characteristics of polygons by finding the distance between 2 points. Okay? So, first thing, there are two main ways of finding the distance between 2 points. Okay, so we're going to take a look at example 1 from page 205 to look at those two different ways. Okay, so you can find the distance. We're going to find the distance between -2, 1 and 3, 4. So the distance between point A and point B. The book takes you through this way here, which is using the distance formula, which works out great. Works every time. You did this in geometry as well. So let's take a look at doing this with the distance formula. Okay, so with that, we've got distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So again, this is, I'm going to call this here x1, y1, and x2 and y2, because that's the first point, that's why they get the 1s, and that's the second point, that's why they get the 2s. Okay, so if we're following right along with this, we take x2, which is 3, so we go 3 minus x1 is -2, and then we square that, and then we take y2, which is 4, minus, and then y1 is 1, so 4 minus 1 squared. Okay, so distance is going to be square root of a minus and negative, so that's 3 plus 2, so that's going to be 5 squared, plus 4 minus 1 is 3 squared. So the distance on this one here is going to be the square root of 5 times 5 is 25 plus 9. So the distance is the square root of, what, 34? Okay. And if the square root of 34 does not satisfy you, you want to know what the actual decimal answer is, that would be okay too. This is actually, officially the square root of 34 is more accurate than the decimal answer that you're going to get, so you can just leave it like square root of 34. But again, if you really want to know what it is, then you can just take the square root of 34 and do this. Do 5 point, oops, I already forgot what it was. Let's do 5.83. 5.83. And if you decide that you really need to have it in a decimal, and it doesn't specify to not leave it as a decimal, this is the exact answer. So this is exact. And then if you write 5.83 where you have to round it off, you would have to do this 3SF, which stands for 3 significant figures, meaning implying that you rounded it, which you did. Okay? So honestly, probably your best bet is just to leave it like that, but this, if you left it as D equals 5.83 and you put the 3 significant figures next to it, then that would be fine too. Okay? So that's one way to do it, distance formula. Another way to do it is to actually use the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay? So with that, let me show you what we do with that. Okay? So basically what you want to do is plot these 2 points on a graph and then turn them into a triangle. Okay? So A is at -2, 1, so -2, 1, there's A. And then B is at 3, 4, so 1, 2, 3, up 4. There is point B. Okay? Now what you want to do is just turn this into a right triangle, and you can either go up and over like that, or you can go over and up like that. Doesn't matter. So I'm going to just go over and then down like so. Ooh, come on, that was pretty good straight lines for me. And the nice thing about this is this makes a nice right triangle here if I connect these 2 points. Now here's where the hard part comes in. Okay. So now we have a right triangle where we can use the Pythagorean theorem. Okay? So really what you're doing here is, here's our two legs. There's the, like say, the a squared and the b squared. Or really I guess that would be a squared because it's across from side a. That would be b squared. Doesn't matter. But anyway, this is 1, 2, 3, 4, 5. So this has got a distance of 5 here. And this has got a distance of 3 here. Right? So to do this, you would just do 5 squared plus 3 squared equals c squared. So 25 plus 9 equals c squared. And look, that should look familiar from right over here. 25 plus 9, 25 plus 9. And we got to square root the c squared to get rid of the squared. So we get c equals the square root of 25 plus 9, which is the square root of 34. Okay? So that's another way to do it, is by basically just graphing it. And you don't even need to have graph paper. You could just, it makes it a little bit handier to have graph paper, but as long as you can figure out how far apart those points are on the x and the y, then you're good to go. Okay? So whichever way you want to do it is fine by me. Okay? Let's take a look at another example. Okay? So example 2 from page 206 says use a distance formula to determine if the triangle ABC, where A is -2, 0, B is 2, 1, and C is 1, -3, is equilateral, isosceles, or scalene. Okay? I'm going to do the Pythagorean theorem way because I find that a lot easier, especially if I'm looking to try to see if what kind of triangle this is. So I'm going to graph these 3 points. So we got -2, 0. Okay, so that's point A. Point B is at 2, 1. Okay, and that is B. And then point C is at 1, -3. So that's point C. Ooh, that was terrible. See, that's what I got for getting all excited about how great a lines I drew earlier. Alright. So we got to try to figure out what kind of triangle that is. Okay. So, in order to figure out what kind of triangle it is, these are all equilateral, isosceles, and scalene are all classified by side length. So we got to figure out what each one of these side lengths are. Okay. So, again, now that we've drawn it on there, let's use a different color. Now I can figure out, to figure out what the length of AB is, I can just figure out this triangle here, which has got 1, 2, 3, that's got a length of 4, and this has got a length of 1. So AB is going to be, let's do 4 squared plus 1 squared, right? So the length, well, it's going to be actually the square root of that, right? Let's do this. Let's back up. So AB is going to be 4 squared plus 1 squared equals, let's go with C squared, right? Because really that C squared is going to, the C is going to be the same as AB. So you know what? Let me try this instead. Let's do this. AB squared. There. How about that? AB squared is going to equal 4 squared plus 1 squared. So AB squared is going to be 16 plus 1. So AB squared is 17. So then AB is just going to be, because we take the square root of both of these, is going to be the square root of 17. Okay, so we figured out what AB is, and I know you're thinking, it's like, well, that was kind of a lot of work. That's just because I drew all this funky stuff out there. So let's do the same thing to find out what BC is and what AC is. So let's do B to C. That is 1, 2, 3, 4. And that is 1. So look, BC is the exact same thing as AB. So let's do this. BC squared is going to be 4 squared plus 1 squared also, right? So then let's just kind of cut to the chase because we just did all the math there. So we know that BC is going to be the square root of 17. So we know that those two sides are the same. So we know it's going to either be equilateral or isosceles. It's not going to be scalene, right? Scalene is where you have 3 different side lengths. So let's figure out what AC is going to be. That is, what, 3 by 3. So AC squared is going to be 3 squared plus 3 squared. So AC squared is going to be 9 plus 9. So that is 18. So we square root both of those, and we get that AC is the square root of 18. Okay? So now we got square root 17, and square root 18. So it's not going to be equilateral either. It's going to have to be isosceles. Right? So let's see, since AB and BC are equal and not equal to AC, the triangle is isosceles. Isosceles. I always have a hard time spelling that. Okay?